One of the things that we've learned about in the last 10 years in sleep research is the fact that in addition to what we call a master clock in the brain, the circadian clock, which determines when we sleep and when we're awake to a certain extent, every cell in the body has a circadian clock. And that has to be synchronized with other cells and also with the environment. So misalignment between the internal circadian clock and the external influences like light and dark, which impact upon the internal clock, as you can imagine, results in profound impairments in physiologic function and in health, and affects virtually every system in the body. Think about how you feel when you have jet lag. It's not just that you're tired, but you can't think straight. You might have gastrointestinal problems. You might have headaches. And that's because of this misalignment between your internal circadian clocks and all those clocks in every system in your body. So the other process which determines how sleepy or awake we are is what we call the circadian drive to wakefulness. And this is a 24-hour predictable pattern of relative peaks and troughs of alertness. So, for example, when we wake up in the morning, our circadian drive towards alertness is fairly low, but our homeostatic sleep drive is also low, so we feel relatively awake. Then we have kind of a surge in alertness mid to late morning, and then around 3 to 5 p.m., siesta time in many cultures, we have a dip in circadian alertness, which many of us kind of respond to by drinking a cup of coffee in the late afternoon. Then, just before our bodies are ready to fall asleep at night, we have a burst of energy, which we refer to as the forbidden zone or the second wind phenomenon. And if you try to fall asleep during that forbidden zone, it's very difficult to do that. So keep that in mind. Then, in the middle of the night or towards the morning, between approximately 3 and 5 a.m., we have the deepest trough of circadian alertness, or the circadian nadir. That is the time of day when we feel most sleepy. But imagine all of this curve and these lines moving about 2 hours later. And you'll start to understand what happens to sleep in adolescence. All adolescents experience a shift in circadian rhythms that coincide with older age and also with pubertal changes. This results in a biologically based shift or delay of up to several hours in both their natural fall asleep time and their morning wake time. On a practical level, this means that because of that forbidden zone, that surge in alertness just before you're ready to fall asleep, it's almost impossible for the average adolescent to fall asleep much before 11 p.m. on a regular basis. Teens cannot force themselves, and their parents cannot make them fall asleep earlier. In terms of wake times, adolescents are also biologically programmed to wake up at around 8 a.m. or later. And early start times for school require teens to wake and function during what is for them that circadian nadir. So remember that typically occurs in adults between 3 and 5 a.m. Well, that gets shifted a little bit later. So we're asking students to wake up and function at a time when their brains are telling them loudly and clearly to be asleep. If that wasn't bad enough, early wake times selectively rob teens of a stage of sleep called REM, or rapid eye movement sleep. REM sleep is concentrated in the latter third of the night, and REM sleep is absolutely fundamental to memory consolidation and learning, particularly of new information. So we're asking these kids to get up at the wrong time, when they haven't gotten enough sleep, and when they haven't gotten the stage of sleep that is most critical for their ability to learn in school. A triple whammy, if you will.